So let's start our section 5.2. It's about compound interest. So on your annual investment, if you are just getting simple interest as we did in section 5.1, that only applies on your original investment, okay? But the compound interest, on the other hand, also applies on the interest you earn. Say I want to show you this using this example. So suppose you deposit $1,000 at 5% interest rate, right? So at the end of 1 year, you will get how much interest? 1000 times 0.505, right? That would be $50. At the end of the second year, how much you will get? Same principle, 1000 times 0.05, again $50. Third year, you will get 1000 times 0.05, again 50 years. So each year interest is only coming on the original investment. But in case of the compound interest, the first year you get interest on $1,000, that is $50, meaning at the end of the first year in your account you have $1,050. Now at the end of the second year, instead of just 1000, the interest will be applied on the money in the account. That means interest will also be applied on the next extra $50 you earned the last year. So the interest will be on 1050, that means 1050 times 0.5 for that year, and you can calculate that interest rate and add it to your last year's value, right? So let's say we have 1050 times 0.05, that is 52.5, meaning we will have how much money at the end of the second year? This plus 52.5. So at the end of the second year, we will have this much money in our account instead of just 50 more. So that is what compound interest difference is. In compound interest, interest is also applied on the interest you are getting in the last period. So it depends upon what are your compounding interest. Are they compounding interest after every 6 months, or that is called semi-annually, or they are compounding interest after every year, or they are compounding interest after every quarter, or they are compounding interest daily, right? That depends on that. So we'll talk about it in this formula. If present value dollars are invested at the interest rate I per period, then the compound amount, the future value after n compounding periods, is given by this. The present value times 1 plus I is the interest rate per period raised to the power n. Or it can also be written as P times 1 plus R by n raised to the power nt, where P is again the same as the present value, n is number of compounding periods per year, R is the interest rate per year. R is the interest rate per year. I is the interest rate per compounding period. That means I is basically R by n. That's why this formula can be written as this. Okay. So let's see how we can use this. Suppose we have $1,000 in the deposited for 6 years in a saving account which is paying 8.31% per year compounded annually. Okay. So let's see what we have given. The principal is $1,000. R, which is interest rate per year, is 8.3%, and in the decimal that would be 0.083 1. Time is 6 years. N is the number of compounding periods. Now we are compounding annually. So N is 1. N meaning number of compounding periods per year. So the amount, find the compound amount. So let's do the A part. Amount formula is given by principal times 1 plus R by N raised to the power N T. What is principal? $1,000 in this case times 1 plus 0.0831 divided by 1 raised to the power N is 1 times T is 6. So this is 1000 times this will be 1.0831 raised to power 1.6. So we can use calculator to do that. 1000, we can just actually say 1 times 6 is just 6, right? So let's use calculator. Times 1.0831 raised to the power 6. So at the end of 6 years, how much amount will we have? 1614.4. That is your amount after 6 years. Now they are asking find amount of interest earned. How much will be interest? Interest is your amount, compound amount minus your principal, right? The present value. So the amount earned is this much at the end of 6 years minus original amount was $1,000. So total interest earned is $614 approximately, right? Let's do one more example. We have example number 2 here. Read through it. If a 16,000 saving account grows to 50,000 in 18 years, what is the interest rate? Assuming annual compounding. So let's load down everything which is given. Principal is given to be 16,000. Time is given to be 18 years. And the compounding periods every year is given 1 because it is given annual compounding. R is unknown. We have to find it. And the amount is given. Amount is equal to 50,000. In 18,000, that 16,000 becomes 50,000. The question is found interest rate. Now, what our formula is, amount is equal to principal times 1 plus R by N raised to the power NT. Amount is given to be 50,000 is equal to principal is given to be 16,000 times 1 plus R unknown divided by N is 1 raised to the power N is 1 times 18. So we have 50,000 is equal to 16,000 times 1 plus R raised to the power 18. So we have to find R. That means we have to isolate R on that side, get rid of everything else. So we can divide both sides by 16,000. That will get me to 1 plus R raised to power 18 is equal to, what is 50,000 divided by 16,000? That is 3.125. So we have to take care of this 18. That means if we take 1/18th on both sides, it should work, right? So that will give me 1 plus R is equal to, using calculator to find 3.125 raised to the power 1/18th. We have 1.065, right? So we can subtract 1 on both sides. We will get R is equal to 0.065, and in the percentage that can be 6.5%. So that is the interest rate at which our 16,000 will convert into 50,000 in 18 years with annual compounding interest. Okay. So you have to just read the question, find your knowns which are given, and then see what is unknown and which has to be found, and we can use our mathematical equations to do that. Let's read our next question. In July 2016, advertised a money market account at LA Bank at the interest rate of 0.85%. Find the value of account if $10,000. So principal is given to be $10,000 for 1 year. Time is 1 year, and interest rate is compounded according to the given periods below, and interest rate is 0.85%, meaning that will be 0.0085 in the decimals. Okay. Now the compounding is given according to either annually or semi-annually or quarterly or monthly or daily. So let me write a small table here. So if we have annually, so what we need to remember that for annually, n value is 1, n is the compounding periods. For semi-annually, n value is 2. For quarterly, how many quarters are there in a year? 4. So n value is 4. For monthly, n value is 12. We have 12 months. And for daily, n value is 365. That is one thing which is changing in each of these. Other than that, the amount formula is same. Here, what is amount formula? Principal times 1 plus r by n raised to power nt. So according to everything which is given, we can say 10,000 times 1 plus 0.0085 divided by n, which is 1 in this case, raised to power 1 times how many years? 1 year. So that is 1. So we can calculate that using our calculators. So it will be 10,000 times 1 plus 0.0085. So that we have 10085. So annual amount for for compounding annually would be this much. Now for this, all it will be changing to is 10,000 times 1 plus 0.0085, but divided by, now it will be 2, because in semi-annually n is 2 raised to the power 2 times 1, and you can calculate that value. Similarly, we have amount for quarterly compounding. Everything else stays the same, but n is now 4. 4 times 1. For n12, amount is 10,000, 1 plus 0085 divided by 12 now, raised to power 4 times. So for semi-annually, n is 2, for quarterly n is 4, for monthly n is 12, and for daily n is 365. And the remaining left is just calculation, so you can do them using your calculator and see how they differ for different compounding periods.